right, here is a problem about distance equals rate times time. So one of these motion problems. And so it says, a man rode a bicycle for 12 miles and then hiked an additional 8 miles. The total time for the trip was 5 hours. If his rate when he was riding the bicycle was 10 miles an hour faster than his rate walking, what was each rate? All right, so there's a bit of information here that's given to this that I already put in the box here, right? So I had written down stuff about when he was biking or hiking. And so on the biking one, we know that he went for 12 miles. So I put that under the distance. And then for hiking, right, he hiked 8 miles after that. So that goes under the distance with hiking. And then the rate, all we're told about with the rate is that he is going 10 miles an hour faster than his rate walking. So we don't know his rate walking or hiking, right? And so I make that H, right? I'm just going to make that, so that is his rate walking. And then it tells us that there's that it's 10 miles an hour faster when he's biking. So all I don't know how fast he's hiking, like the rate in which he's hiking, but I know that he's biking 10 miles an hour faster. So I've got to make sure that I'm putting those things in there. So we only want to use one variable, so that's why I have here that his rate hiking is H and his rate biking is H plus 10. And all we know about the time is that it takes him 5 hours total, right, to be able to do both of these things, to bike 12 miles and then hike 8 miles after that. Okay, so let's think about how we might set this up. So all we know about time is that it is 5 hours, but I can get my distance and rate in terms of time, and then I'll be able to use this 5 hours. So looking over here at the distance equals rate times time problem, right? If I was solving this for t to get time by itself, I would need to divide both sides by r. So time is the same thing as distance divided by rate. So my distance divided by rate here is 12 over h plus 10. And then on hiking, it's 8 over h. And then these two together need to add up to be 5 hours. Okay, so let me write over here how I'm going to set this up. So I'm going to have my first fraction of 12 over h plus 10. And then I'm going to add that to, right, because this is just the time that it's going to take him to bike that amount. Now we need the hiking, so it's going to take him 8 over h hours to hike that amount. And then together, it needs to add up to be 5. Okay, so here's my equation that I'll be using. And notice that my variables are in the denominator. And so I actually need to kill these off. It's really hard to solve for these when they're in the denominator. And so one of the biggest things that you've learned in this chapter is about how to solve these rational equations by eliminating those denominators, right? And we do that by multiplying every part by the LCD. So if I'm looking at this, right, my LCD here is h plus 10. So I know that needs to be part of my LCD, right, the h plus 10. But then h is my other part. So my LCD is really h times h plus 10. And this 5 is just over 1, so there's no denominator there that I have to worry about. But I'm going to take this LCD and I'm going to multiply each part by it. Right? And I do that so that I can kill off my denominators. So it's kind of like I have this over 1, and then I've got this one, that same thing, h times h plus 10 all over 1, and then I need to multiply 5 by that. Now this is where a lot of people forget you got to multiply every single part by that LCD, so this also needs to be multiplied by h times h plus 10. All right, but let's look at this first fraction here. On this, I can see that I have a common factor that I can divide out. I have that h plus 10 and that h plus 10, right? That whole thing is going to divide out. And then I'm left with just 12 times h. So I have 12h here. All right, on my second fraction, I can see that my h in the denominator is going to divide out with that h. So it's really important that I'm killing off this denominator, right? That's what I'm trying to do. I'm not going to be ending up with a denominator here. But what I'm left with in the numerator is going to be 8. So I'm going to put plus 8 times that h plus 10. Okay. And now let's go to the other part over here. And this is going to be, I'm going to write it this way so it's a little bit easier to see. So 5h times h plus 10. Okay, I've got to multiply all of those together. So let's go ahead and simplify this. 12h is great just how it is. There's nothing to simplify here. But here I need to distribute that 8 through. So I get 8h plus 80. And then here I'm going to distribute that 5h through to both of them. All right, so 5h times h is 5h squared, and 5h times 10 is plus 50h. All right, so now let's simplify what we have here. That adds up to be 20h. And then I still have plus 80 equals 5h squared plus 50h. All right, so now looking at this, I've got to look and think, okay, how am I going to solve this? Well, I have an h squared there. So whenever I have an exponent of 2 or higher, I need to move everything to one side of the equation so that I can try and solve it by factoring. So I'm going to first of all move that 20h over. So let's subtract 20h there. And I'm going to subtract my 80 over. All right, which is going to leave me with 0 on this side, which is what I was hoping for. And then I have 5h squared. Let's add these together. So I get 50h minus 20h is going to give me plus 30h. And then nothing to combine with that negative 80, so I'll bring it down. All right, so now I need to, solve this by factoring. It's set equal to 0. But when I look at this, the first thing I always want to look for when I'm factoring is there a greatest common factor? And on this one, there is. I can see that 5 can divide into each of those terms. So I'm going to first do that. Let's divide 5 out of each of these. So I'm going to have 5 is on the outside. If I divide that out of the first term, I'm left with h squared. Divided out of the second term, I'm left with 6h. And then if I divide it out of the third term, 80 divided by 5 is 16, and it's a negative 80, so negative 16. All right, now this looks like it's going to make it easier to factor here. All right, so now I'm going to go ahead and write this out in factored form. What times what is h squared? Well, that's h times h. And remember, I can go straight to these parentheses like I have here because my leading coefficient on that h squared is just a 1. If that was something else, then remember you have to do like that factor by grouping, the AC method. You have to go about that differently. But there's a 1 here, so I can go straight to my factoring. And then I'm trying to think, what times what is negative 16 that adds to be 6? Well, I know that 8 times 2 is 16. And to get a positive 6, then I must have my 8 is positive and my 2 is negative. All right, so now we can set these parts equal to 0 and solve. Now notice on this 5, there's no h there to solve for. So, sometimes I have students write this and be like, oh, one of my answers is 5. Well, that's not true because really that's just nonsense. 0 doesn't equal 5. There's no h to solve for there. So we're really looking at these other two parts. So I've got h plus 8 equals 0, and then h minus 2 equals 0. All right, so on this one, let's subtract the 8 over, and then I get h equals negative 8. Well, let's think about that. What is it that we were trying to find, right? We said that h was the rate, right? A walking rate. Can you go negative 8 miles per hour? No, that's not possible. So this is an extraneous solution. We're not going to be using that one. Okay, however, our other one, if we add the 2 over, then we get h equals 2. So this is the one that we want to use. Okay, now what is this, right? So let's go back up here and look and see again what we had. All right, so we said h was the rate walking. So I'm going to write over here. So he's going to go 2 miles per hour when hiking, all right, because that walking was the same thing as when he was hiking. All right, and then how are we going to figure out how fast his rate when he was biking? Well, I'll put 2 in place of this h here. All right, so I'm going to have, so I'll just write it here, right? So 2 plus 10 gives me 12. So he's going 12 miles per hour when he's biking. Okay, and let's just make sure that we found what it asked for. It asked us to find what each rate was. So we found 2 miles an hour when he was hiking and 12 miles an hour when he was biking. Okay, I hope that was helpful.